Okay, we are back. Sorry about the delay. I had to get a calculator because both the ones that I had had dead batteries. But all right, we're good to go now. We're back in business. So, like I was saying, we can't compare grams to grams by comparing apples to oranges, but we can compare a mole to a mole to figure out the empirical formula. That's what we're going to do next. So nitrogen has a molar mass of 14 grams per mole. And then the oxygen, 74.1 grams of oxygen, has a molar mass of 16 grams per mole. All right, so we'll take and figure out how many moles we have. All right, so in that sample, we're going to have 1.85 moles of oxygen. In that same sample, we are going to have 4.63 moles of nitrogen. Okay, so the end goal here is to figure out the empirical formula of this compound. So what we're trying to do is we're trying to figure out X and Y. We're trying to figure out those subscripts. First thing we did is we made a 100-gram sample assumption. Then we converted it to moles, the grams to moles. Now we can compare moles to moles. All right, I could write this as this right here, but we want the simplest whole number ratio, and right now we have 1.85 nitrogens per every 4.63 oxygens. That's not going to work for us. So what we do is the final step is you divide by the smallest number, like I'm going to do right here. And the reason for that is we're going to get a whole number. Because if I take this and divide it by that ratio, I'm going to get nitrogen 1. And then I'm going to take the 4.63 divided by 1.85, and I'm going to get oxygen to 2.5. We're very close now, because we know that for every nitrogen atom in this compound, there's going to be 2.5 oxygens. So we're really close. We have to do one more step with this one, and it's because we have that half. Well, the easiest way to get rid of the half is to double both subscripts. So in this case, it's going to be N2O5. That is going to be the empirical formula of that sample. So kind of a really neat calculation. We just figured out the empirical formula of the sample just by looking at percent data, which will be found in the lab using a fancy contraption like this. So I'll let you guys kind of think about what we did here. Quick recap. What we did, we assumed we have a 100-gram sample. And therefore, we can take those percentages, turn them to grams. We can't compare grams to grams. We have to compare moles to moles. So in step 2, convert it to a mole. Okay. Now step 3, write it using those mole ratios. Divide by the smallest one, like we did here. So we got N1, O, 2.5. Sometimes it works out evenly, where we don't have to double it. But this one we had to double it, take that extra step, and we got N2O5. All right, so let's look at a few more. Practice makes perfect. Let's try these problems right here. So what is the empirical formula of each of the following compounds? All right, on your notes, don't forget this. Make that 100-gram sample assumption. So let's just say we have a 100-gram sample of each. So what we can do is just call it grams and grams. All right, we can't compare grams to grams. That's like the apples to oranges. So step 2, let's convert both those gram samples to moles. So I have 36.1 grams of calcium, and I have 63.9 grams of chloride. We have to convert them to moles, then we can compare moles to moles. Calcium's molar mass is 40.1. so 1 mole per 40.1 grams. Chlorine's molar mass is 1 mole per 35.5 grams. All right, so let's figure out how many moles of each we have. All right, so for the calcium, we're going to get 0.999 moles in that sample. For the chlorine, 3.9, we are going to get 1.8 moles of the chlorine in that 100 gram sample. Some of you are saying right now that's going to be a 1-to-2 ratio, and you'd be absolutely correct. If you can't see that, then the next step would be to write the formula using those ratios. So I'm going to go calcium 0.9, chlorine to 1.8. Some of you can see probably right now it's a 1-to-2, right? It's 1 calcium to 2 chlorines. If you can't see that, then take the final step, divide it by the smallest number, and that way it'll give you a simple whole number ratio of 1. So you're going to get calcium to the 1, right? That's just 1. And then 1.8 divided by 0.9, that'd be 2. So this one wasn't too bad. We divided it out, and we got a nice even number there. So then the empirical formula is going to be CaCl2. All right, let's look at another one. This one's kind of fun because we have 3 elements. So step 1, make that assumption. Convert those percent signs to grams. Step 2, convert the grams of each of those to moles. So I have 40 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of oxygen. And again, this percent data is from that fancy piece of equipment. But now let's figure out how many moles of each we have. So carbon's molar mass is going to be 1 mole per 12 grams. Hydrogen, 1 mole per 1 gram. And oxygen is going to be 1 mole per 12, or no, oxygen 16, sorry, per 16 grams. All right, so 40 divided by 12. So in that sample, we're going to have 3.33 moles of carbon. We are going to have 6.7 moles of hydrogen. And we are going to have 53.3 divided by 16, 3.33 moles of oxygen. Some of you could probably see it already without having to take these extra steps. You can probably see it's a 1-to-2 to 1 ratio, but if you can't see that, it's okay. Just write the formula, CHO. Write in those values that you just calculated, and then divide it by the simplest number, which is 3.33. And then when you do that, you're going to see it's C, H2, and O. So the empirical formula of that sample would be C, H2, and O. So as you can see, this might be sugar. This sample might be sugar. But with this process, as of right now, we can only figure out the empirical formula. There's another step that we would do to figure out the actual molecular formula. And I'm going to show you what we do and how chemists figure that out later on. All right, so let's look at another one real quick. We have 1,6-diaminohexane is used to make nylon. What is the empirical formula of this compound? So step 1, just change those to grams. Make that 100 gram sample. Step 2, convert those grams to moles. So this would be 1 mole per 12 grams for the carbon. Then we're going to have 13.8 grams, 1 mole per 1 gram. And then we're going to have 24.8 24.1 grams, 1 mole per 14 grams. All right. So step 1, make your 100 gram sample. Step 2, convert all of those to the moles. 62.1 divided by 12, and I get 5.175 moles of the carbon. Hydrogen, I get 13.8 moles of hydrogen. And then finally, 24.1 divided by 14, I get 1.72 moles for the nitrogen. Okay. This one, some of you may be able to see the ratio without dividing it out, but because there's 3 here, we have 3 different numbers. I'm actually going to write it out and see what we get. So we're going to have carbon, hydrogen, and nitrogen. So we have carbon, we found to be 5.175. Hydrogen, we found to be 13.8. And nitrogen, we found to be 1.72. All right, so the next step is divide by the smallest number. That way we can get an even value. 0.72, 1.72. Okay, so 5.175 divided by 1.72. For the carbon, I get 3. For the hydrogen, I get 13.8 divided by 1.72. For the hydrogen, I get 8. And then for the nitrogen, you should get 1. We take that and divide it by that. So there would be the empirical formula of that compound. I'll stop, let you guys finish writing that in. So they're really not too bad. It's just a couple steps that you guys got to do. Step 1, convert it to grams. Step 2, convert it to moles. Step 3, write it with those mole ratios and divide by the least amount. So that's all there is to it to figure out the empirical formula of a compound. So now the molecular formula of a compound is either going to be the same as the empirical formula, or it's going to be a multiple of that empirical formula. And I'll show you how chemists figure that out. Let's see, really here's kind of an example of showing you guys that all of these would have the same empirical formula, CH2 and O. So you have methanol, glucose, and ethanoic acid, 3 different substances, but they have the same empirical formula. So how do we figure out which is which? So this experiment here gets us that percent data. This experiment here would get us the percent data so we can figure out the empirical formula. So okay, how can we figure out the actual molecular formula then? So here's what chemists do. They run it through what's called a mass spectrometer. And here's what they do. They send a sample, they charge it up, the heater's going to vaporize the sample, and then they send it through the mass spectrometer, and then down here is the detector. The heavier the molecule is, the less it gets bent by the magnet, because it's going to be attracted to it. So the heavier it is, it's going to land right here. The lighter it is, it'll land right down here. And on this detector, it's going to be calibrated to figure out the molar mass. So what they can do is figure out the percent data, and then they can use the mass spectrometer to figure out the molar mass. And once you know the molar mass, you can figure out the actual molecular formula of the compound. And let me show you how that's done. All right, it says calculate the molecular formula of a compound whose molar mass is 60 grams per mole, and the empirical formula is CH4N. So this is the empirical formula. This was found from percent data, right? This is what we just did. So a chemist would figure out percent data, they would get the empirical formula. Then step 2, what they would do is they would figure out the molar mass. So this is the actual molar mass of the sample. And that's found by running it through the mass spectrometer. So here's what we do. You figure out the molar mass of the empirical formula. So in this case, we have CH4N. So first figure out the molar mass of the empirical formula, which this is going to be 12 plus 4 plus, and then the nitrogen would be 14, I believe. Just double checking. Yep, 14. So add all that up. 12 plus 4 plus 14. And I get a molar mass of 30 grams per mole. Okay, so the empirical formula has a molar mass of 30 grams per mole. But when we ran the sample through the mass spectrometer, we figured it out to be 60 grams per mole. You might be able to see that it's double. So basically the value's been doubled. So what we're going to do is we're going to double the empirical formula, and we're going to actually write the real molecular formula. So C2H8, that does not look like a good 8, C2H8N2. This is going to be the actual molecular formula. And if you were to figure out the molar mass, you're going to see that it is the 60. I'm going to do a couple more of these problems, but that's how we do it. You first figure out the empirical formula, then you figure out the molecular formula based on the molar mass. So let's look at another one. I'll try to make it as simple as possible for you because now you guys know the idea. So I'm just going to do just the steps. It says, what is the molecular formula? So we're trying to find the molecular formula of a compound with the empirical formula of CClN and a molar mass of 184.5 grams. So we have CClN. That's going to be the empirical formula. Now the molar mass of the empirical formula would be 12 plus 35.5 plus the nitrogen would be 14 again. So 12 plus 35.5 plus 14, and I get a value of 61.5 grams per mole. Okay, so that's the molar mass of the empirical formula. What you can do is then divide it by the molar mass of the real formula, and you're going to see that it is about 3. So that means that the actual formula is going to be 3 times larger than the empirical. So then the actual formula is going to be C3Cl3N3. That's going to be the molecular formula. And again, you can double check it by doing the molar mass calculation, see that it is 184.5 grams per mole. And I'll let you guys do that, but that's how it's done. All right, let's try another one. It says, find the molecular formula of ethylene glycol, which is used as antifreeze. The molar mass is 62 grams per mole, and the empirical formula is CH3O. So step 1, figure out the molar mass of the empirical formula. That's what I'm doing right here. So I get 31 grams per mole is the actual empirical formula. Well, when you look at the molar mass data found from the mass spectrometer, it's actually 62. So it's 62 grams per mole, so that means it's going to be double. So the molecular formula is C2H6O2. That would be the actual molecular formula. All right, so it's that easy for you. Now, there might be some questions on the homework where it says, what's the actual molecular formula? and you do the molar mass calculation and you get 62, well, and it matches up with the 62, well, that's just telling you that the empirical formula and the molecular formula are the same. So if you see that in the homework, that's what it means. But that's a wrap on empirical and molecular formulas.